Welcome to homework.
All right, so first thing I'm going to do is I'm going to take the length of I have in micrometers squared, and I'm going to convert that, right? So I'm going to say that 1 micrometer is 10 to the negative 6th meter squared, and then 1 meter is 1,000 millimeters. And again, squaring that whole thing, and that is going to give me 1.0 times 10 to the negative 6 millimeters squared. All right, so what I'm going to do with that now is I'm now going to multiply that by the tensile strength of asbestos, and that's going to give me the weight of that strand, right? So I can say 3.5 times 10 to the squared, and that's kilograms per millimeter squared, times 1.0 times 10 to the negative 6th. It gives me a strength of 3.5 times 10 to the negative 4 kilograms. Okay, so now I'm given the other units in pounds per inch squared. So I'm going to convert that to kilograms per millimeter squared, just so all of my units match. So if I have 1 pound per inch squared, right, basically I'm going to say that 2.205 pounds is 1 kilogram. And then I can say, to get rid of inches, I can say 1 inch is 2.54 centimeters. Since inches is squared, I'm going to square this whole term. And then I'm basically going to transfer from centimeters to millimeters. So I can say that 1 centimeter is 100 millimeters. And same thing, since centimeters is squared, I'm going to square this whole term. So when I do that, I'm going to convert my two tensile strengths. For aluminum, that's going to, basically what I'm going to do is I'm going to take the tensile strength and just multiply it right here, right? So instead of having this 1, right, you basically just plug in the two tensile strengths it gives you for aluminum and steel. Once you do that, for aluminum, it gives you a tensile strength of 0.176 kilograms per millimeter squared. And for steel, I'm going to call it S, that gives you 0.351 kilograms per millimeter squared. Okay, so now basically what I'm going to do is, using this value right here, I'm going to figure out the millimeter length that I would do. So how I would do that is pretty simply, I would say steel. I guess it has aluminum first, so let's do aluminum first. So I would do aluminum is equal to 3.5 times 10 to the negative 4th, that's kilograms, over 0.176 kilograms per millimeter squared. And that gives me a value of 0.00199 millimeters squared. So very, very similarly, I'm going to do pretty much the exact same thing, except I'm going to say that for steel, I'm going to have 3.5 times 10 to the 4th kilogram divided by, and this time it's going to be 0.351. And that is also kilograms per millimeter squared. All right, when I do that, that gives me a value of 9.97 times 10 to the negative 4th millimeters squared. And those are our two answers right there for aluminum and right here for steel.